Multi-agent environments can be competitive, like a racing game, cooperative, like robots assembling a product, or a mix of both. A semi-dynamic environment doesn't change, but the agent is timed, like a chess clock. A dynamic environment changes constantly, like traffic conditions for a taxi. In dynamic environments, agents must be fast, adaptive, and responsive. Hi everyone and welcome back to Farzin Academy. I'm Farzin and in today's lesson we will explore an important concept in artificial intelligence, the task environment. Understanding the task environment is the first step in designing intelligent agents. Let's see how it works. So, what exactly is a task environment? It's a formal description of the problem that the intelligent agent is trying to solve. To define a task environment, we use the P's framework. P for performance measure, E for environment, A for actuators, and S for sensors. This framework helps us think clearly about what the agent needs to achieve, where it operates, and how it perceives and acts. In summary, the P's model is the foundation for designing intelligent agents with clear goals and structure. Let's apply the P's model to a real-world example, an automated taxi driver. The performance measure includes safety, speed, legality, and passenger comfort. The environment is the road system. The actuators are things like the steering wheel, accelerator, brake, and horn. The sensors include GPS, cameras, and radar. This example shows how an AI agent in the real world must handle multiple goals, work in a complex environment, and use diverse tools to perceive and act. In summary, Peas helps us structure the agent's design by clearly separating what it must do and how it interacts with the world. Now, let's dig deeper. Task environments can have different properties that affect how we design agents. Here are some key factors: observability, number of agents, determinism, sequential dependency, dynamism, continuity, and knownness. Each of these properties helps us understand how predictable, visible, or complex the environment is. In summary, knowing these properties helps you choose the right strategy for building your AI. Let's begin with observability, how much information the agent gets from the environment. In a fully observable environment, the agent can see everything it needs to make decisions, like a chess game. In partially observable environment, only some information is available, like an automated taxi driver might not always detect obstacles or pedestrians. In an unobservable environment, the agent receives no useful input, for example, a blind conveyor belt with no sensors. The more an agent can observe, the better its decisions, but we often have to work with partial or limited data. Next, let's talk about how many agents are involved. A single agent environment means the agent works alone and isn't affected by others. For example, solving a Sudoku puzzle. A multi-agent environment means the agent must consider the behavior of others, like our automated taxi must interact with pedestrians, other cars, and traffic signals. Multi-agent environments can be competitive, like a racing game, cooperative, like robots assembling a product, or a mix of both. In summary, multi-agent environments require coordination, prediction, and sometimes negotiation. Hey, if you're finding this lesson helpful, please take a second to like this video and subscribe to Farzin Academy. There is much more to come in this course, and your support means a lot. Now let's look at determinism. Does the same action always lead to the same result? In a deterministic environment, outcomes are predictable. For example, moving a piece in chess always gives a known result. In a non-deterministic environment, outcomes vary even with the same action. For example, taking a turn in foggy traffic. A stochastic environment is a special case of non-determinism where outcomes have probabilities. For example, if there is a 75% chance of rain tomorrow, that's stochastic. The more certain the environment, the more the agent must plan for different possible outcomes. Next is sequential dependency, whether decisions depend on earlier actions. Episodic environments treat each situation as isolated, for example, assembling parts in a factory. Sequential environments require long-term planning, where one decision affects future choices. For example, playing chess, where a bad move early on can lead to defeat later. In summary, sequential environments need agents with memory and strategy. Now let's talk about dynamism. Does the environment change on its own? A static environment stays the same unless the agent acts, like pseudocode. A semi-dynamic environment doesn't change, but the agent is timed, like a chess clock. A dynamic environment changes constantly, like traffic conditions for a taxi. In dynamic environments, agents must be fast, adaptive, and responsive. Now let's talk about continuity. Are these states or acting discrete or continuous? In a discrete environment, everything happens in steps, like moving pieces on a chessboard. In a continuous environment, there are infinite possibilities, like a car driving where speed, position, and time are continuous variables. Most real-time environments are continuous and require more complex control systems. And finally, let's look at knownness, how much the agent knows about the environment rules. In a known environment, the agent understands how things work, like game rules or physical laws. In an unknown environment, it has to learn through trial and error. It's important to note that knownness is different from observability. For example, a smart taxi might operate in a known but partially observable environment. On the other hand, a player in the Squid Game might face a fully observable but unknown environment. An agent's knowledge on the rules shapes how it learns and plans. That wraps up our lesson on task environment and the P's framework. We explored how to define a problem for intelligent agent and how different types of environments affect AI design. If you enjoyed this video, please like, subscribe, and share Farzin Academy with your friends. Thanks for watching, and I'll see you in the next lesson.